Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our D programming language series. In today's lesson, we're going to talk about reduce. So if you've watched the previous lessons, you know that we've talked about map and filter, and that leaves reduce for us to talk about. So let's go ahead and see this library function in the library reference here from the D programming language website. And again, this is part of algorithm, and we're going to find that this is part of iteration. Now, looking through iteration and talked about reduce, if you've seen this in other programming languages, you might have seen it go by other names like fold. And you might also notice that fold is also part of the D programming language standard library, Phobos here. But we're going to talk about reduce. It executes relatively similar to fold. Reduce has a parallel version, and the arguments are flipped around. That's the main difference. And there's also a cumulative fold, which is an interesting function to look at, but maybe we'll look at that later on in the series as we look at more of the standard library. But for now, let's just go ahead and try to understand what reduce is doing. And I think a nice way to think about what reduce is by, well, some of the other names that this function might go by in other languages. So if you're coming from a C++ background, you might have seen standard accumulate, for instance, and that's the basic idea here. We're trying to accumulate or compress. That is to take multiple results, so maybe an array, for instance, or some other container, and reduce it down to one value. So let me go ahead and illustrate this with a drawing just to make this clear here. And the basic idea, let's go ahead and leave our reference up here. Here's reduce. And the basic idea is if I have some collection here, 1, 2, 3, and 4, I might want to ask some question about this container here, whether it's an array or maybe a list or some other data structure, but basically figure out what can I reduce this into. For instance, what would the sum of 1, 2, 3, and 4 be? Well, that would be 10 here, 1 plus 2 plus 3 plus 4. So that gives us a basic idea of what reduce is doing. We're looking at each element one at a time and performing some operation to answer this question. So 1 plus 2 plus 3 plus 4, that reduces this set of data to 10. But there's other ways that we can sort of reduce here. Maybe we want to ask what the maximum or minimum element is, or perhaps some other summary statistic. Maybe find the average of all of these elements here, which again we could do by reducing this to the sum and then dividing it by the length of the container. And we could probably imagine other sort of interesting operations if we don't have integers. So for example, what if I have an image here, and if I draw it and represent it each very quickly as a grid, and I put in some data here, like a smiley face, and I have the pixels, well, maybe I want to reduce or perform some operation on each of these pixels here. And previously, we've learned an operation that can do that, like map, for instance. And then maybe I want to actually look at that pixel data and compute some sort of average on it. So again, that's where you could use reduce. So again, you can think about how to play with some of these tools, map, reduce, and filter. They tend to work nicely together. And again, a lot of functional programming languages tend to package these in their library or are built into the actual language. Now, D has this in the library. I think it's a really useful function. There's also parallel versions of it, which may also be useful depending on the task that you're trying to solve. So anyways, I hope this gives a basic idea of what reduce is, but I think a way to understand it is to actually just implement a very simple implementation of reduce to understand what it's doing. So what I'm going to go ahead and do here is code up just a simple version here. I'll call it reducer or something like that. And typically what we want to work with, let's go ahead and just assume we're going to work with integers for now. And the basic idea, as I showed here in this previous example, let's go ahead and just rearrange these windows here, is I want to reduce this data here to something, again, like a singular integer, okay, or some value, whatever type you're working with. So in this particular case here, I was taking these values and summing them up, 1, 2, 3, and 4. So in order to do that in a function here, I usually have some sort of accumulator here, and I'll abbreviate that accumulator. I'll just write it all out. We have plenty of space to do that, but that's the basic idea here. And then I have my input. Okay, so that's a basic idea. And then probably some sort of return value here, like an int. Now, in order to make this a little bit more generic, I think it is useful to actually just do auto and maybe template this. And again, this is going to be closer to the actual implementation that you might see here, but that's the basic idea here. Okay, we haven't really talked about templates yet. That's coming up, so say subscribe for that. But now we could take in any type here, whether it's a float, integer, or whatever, and accumulate them. So basically what I'd be doing is some sort of for each element that's in our input collection. And I would just be taking our accumulator here and adding each of the elements here. to that accumulator. That value might be 0, it might be something else, but that's the initial value. Maybe it's just the first value in input. You get to decide here. And then what we want to return here is the actual accumulator. Okay, so let's go ahead and provide some data to this. And I'll just create an array here with 1, 2, 3, and 4. And let's just write out, if I call that reducer, the 0 will be the initial accumulation. I haven't added anything yet. And then my input is our array. And let's go ahead and see when we run this what happens. We get 10 here. So a few things to note. 1, our function works. 2, we're not going to get too hung up on the templates here, but D is smart enough to infer that, yeah, we're just working with integers here. So we didn't need to specify the type here. But what you will see, for example, is sometimes specifying the type is necessary. So we could go ahead and do that. If we have 1 or multiple template arguments, again, we'll get into templates later on, but D is smart enough to figure this stuff out here. But the other thing is, I probably want to be a little bit more flexible than just adding our numbers here. So this actual sort of template that we're going to provide here, or that you're going to see in the library, is going to be for, well, what's this operation supposed to be for each element as we're looking through them? Meaning that, what if I wanted to actually multiply these, or maybe add them first and then multiply them and then divide by 20 for each of the successive steps that are performed. So with that said, let's actually look at the D Phobos implementation in the standard library here. And I'm going to comment this out here because it's not as interesting to us, but I think it sort of gets you the point here. We'd want to make this a little bit more generic so we could do more interesting things here, like being able to multiply or add the numbers or whatever. So anyways, let's go ahead and look at reduce. We'll go ahead and open up our examples here. And let's just go ahead and try a few out. Now, again, the advantage of using reduce versus putting things in a loop is we can actually save the result. We've looked at that in the previous map and filter video. I'll probably do it again here, but let's go ahead and just work with reduce for now. And what we're going to go ahead and do for reducing this is do A plus B, and then I'm going to provide our collection here. And let's go ahead and see if we get the same result here. And we do. We get 10 here. Okay, so this is the reduce function here. Here it is. Here's the function for its input here. And we're calling it on this array here. Okay, so using D's universal function call syntax, let's go ahead and just flip things around if you prefer. Sometimes this is a little bit cleaner here. But you can see that's the same result here, right? I'm taking this array here. I want to reduce it or perform this operation. Okay, I'm taking 1. I'm adding it to 2. I'm getting a result of 3. I'm taking 3, adding it there because I'm accumulating. I'm only looking at these values one time. And then I'm getting a result of 6. And then 6 plus 4 gives me 10. So you get the idea here. So again, you can play around and change these functions in different ways here, where A is representative of the first input here and B the upcoming or the next element in the container. That's a way to think of the initial what we're looking at here. And then A is where we are accumulating the result here. So another way I could write this out, actually, let's write this as A equals A plus B here. And you see that we get the same result here. Okay, so no change there. And I'm curious, actually, if we put something like B here, let's see if that really messes things up here. I guess it's still going to work, which is kind of interesting here. But let's go ahead and get rid of that. Usually that's not how you write things. Let's go ahead and write this actually with the Lambda version as well here. So instead of providing a string of A plus B, I'm going to take in the arguments A and B and then just return A plus B here. And that should do the trick here. Oops, let's see if I missed a semicolon. Oops, didn't miss a semicolon. I actually just mistyped this out. This is the template argument here that's being provided here. And again, what I have here for the string is the function that's executing on this array here. So I still need to provide that value here. Now, let's see if I get into trouble here, right? I need my accumulator here. Now, is D going to be okay if I use this universal function call syntax here? Let's go ahead and see what happens here. I do get a bunch of errors here. That's because I think my parentheses are still off. There we go. And I am getting some issues here, okay? Let's actually make this a little bit bigger, then I'll show you what the fix is, or a possible fix here, depending on what you're doing. Let's go ahead and rerun that here. And saying error, none of the overloads of the template, main, reduce, etc. are callable using these argument types, where I provide the array first, which is what I'm trying to do with the with this function here. But basically, what this is getting into is something I alluded to at the start here, where if we look at the fold function, actually, I think it says here, there is fold, which does the same thing, but with the opposite parameter order. Okay, so I can call this using the universal function call syntax, which I tend to like here. Let me just give you the fix here, because that does take the array as the first argument here. So you might prefer that here. Okay, just depends on what you're trying to do. So for this, I do need to provide 0 for the accumulator, very similar to what we did in our reducer function, and then provide the array after. And then let's go ahead here and go ahead and show that it works here. Okay, so we've got the string version here. Then we've got the UFC, so universal function call syntax, UFCS, which is a great feature of the D programming language. And then we've got the lambda version here. Okay, taking a binary function. Okay, and what I mean by binary function, you might see this show up in an error or something. But that means it's a function that takes in 2 parameters here. And that's the idea here. Okay, so there is now with reduce also other versions of this function that just take in 1 value, for instance. So let's go ahead and write this out here. Oops, how about we do this? If I just pass in 1 value here, and for this actually I'm going to refer to, they've got some nice examples here. Let's go to, let's just stay in reduce here, of something that you might want to do, again, which is just to take the max here. Now let's see, I'm going to need the algorithm comparison library potentially here, but let's just try to pass in max here into reduce as the template argument. Now let's see if that gives us the maximum element. So this is the unary function, which just takes in 1 argument. Okay. And this, in fact, works here. Okay. Looks like, yeah, including standard algorithm here, we get max here. And we're able to quite nicely reduce this collection or ask a question about it and just retrieve the maximum element. Okay. And again, in my mind, this is something that's a little bit cleaner than having to write a for loop, which you iterate through and keep track of the maximum element. Again, these are the types of things that will just save you a lot of time, in the sense that it's a little bit harder to make a bug here. It's encapsulated. So again, I tend to like using map, reduce, filter, sometimes in combination with each other because of the universal function call syntax, because it's relatively easy to see what's going on, or if you're reading someone's code, you can understand relatively easy what's going on, and you can change this functionality relatively easily if you need a min or a max, or maybe some other new idea, and you just see that, well, this is the way to do it. So again, this can come in handy when doing various data processing tasks. Now, reduce, just like map and filter, can actually take in multiple collections and return a tuple. So let's go ahead and see how to do that here. And let's go ahead and provide, this time, the min and the max here. And let's go ahead and just say auto. I'm just going to call this results. Actually, let's make sure that we do this in a separate block here, just to preserve what we've done. And what I'm going to go ahead and do here, let's see here. Auto result. And let's take we want the min and the max here. Let's go ahead and run it, make sure it runs here. Oops, let's see, what have I done here? Reduce. And I think I've just got an extra. There we go. Okay, let's see. Static assert seed int should be a tuple. Okay, I'll get back to that, but that's where I have this value 0 here. I think I could get away with just getting rid of it here, and it'll be okay. Yeah, it'll be okay there. So let's actually write out the result here. First thing I'm going to do is just write out the type of the result, like we've done in previous videos. Result type, just so you can see that we are in fact getting a tuple of 2 integers here. And then let's go ahead and write these out here. Let's go ahead and write them out as result 0. And that should be our min. And then we'll go ahead and write out the max as well, which should be in result 1. I'm expecting 1 and 4 here, which is 1 and 4, the minimum and the maximum values here. So that's quite clean here to be able to just return a result. Again, if you're doing a bunch of summary statistics, for instance, I mean, an obvious application would be doing a spreadsheet or something where you want to take in a bunch of values, compute the min, max, average, whatever, functions that you would supply here. And that's basically it. In fact, I'm kind of curious here. This is a little bit of a tangent, but we should probably write our own. I'm just going to call it my max here. And again, it's going to be a unary function here. And let's just take in a collection. And basically, I just want to find the largest value here. Okay, let's assume they're all positive for now. Let's just say max, so usually you do something like set it to equal to, a really small number here. I forget what in Dlang the max value is, but basically let's just look at for each element in the collection. And then we'll say if max is greater than the element, then the max is now the element's value. And then we'll return the max here. Okay, so let's make sure it works. Right line, take in my max. Oops, from the array. Oops, what did I do here? Negative 9999, that's not right here. If max is less than the element. Yep, there we go. All right, there we go. There we get 4. And then let's just actually pass that in here. Let's see if that works here. And that should be all we need to do here. Max, my max. Let me make sure there we go. And now we've got a third result here. And we can verify that it works. Let's get rid of this. Or I'll just comment it out so you can see what the point of that is. We run it and we get, uh-oh. Now, again, let's try to just decipher this. Again, D gives us pretty good error messages overall, but it's telling us, hey, this function, my max here, it's not callable using arguments of int and int, okay? So it's actually, a little bit different than what we did with our reducer function here, where, again, the actual logic of, well, sort of iterating through this and determining which number is the max. So let's go ahead and change the implementation here to just take int A, int B, and we're simply just going to return. And let's see here. And we can do this as a, A greater than B. And then we use the ternary operator to determine if A is greater than B, then return A, otherwise return B. Let's see if that satisfies. And in fact, it does here. Okay. So again, the actual reduce is doing the hard work of rather, iterating through these things one element at a time, right? With A and B. So just as we saw with, A and plus B here, that's effectively what these max functions are doing here. So actually this is still a binary function. I don't know what I did there. That's a little bit of a mistake. Binary function. I'm assuming max is still looking at 2 values and not doing anything too clever there, because we do need to be able to reduce them. So little error there, but that's how we learn stuff, by sometimes trying to implement it from scratch and just playing around with the functionality. And of course we see our function working here. Okay, so anyways, that gives you an idea of some of the different things that you can do. And again, reduce is one of these higher order functions that allows us to, well, take some sort of function as its input, perform some sort of operation, whether adding things, subtracting them, etc. And again, doing something interesting. The last thing that we should do here is actually save this result here. Again, since reduce is just, for instance, well, I guess this is a good enough example here, but we might want to do one last thing here. Again, same sort of trick that we've been doing before. I'm just going to import this at the top here. But you might want to take your results tuple, convert it to an array here. Again, just to show that you can get, all these values, if they're meaningful, from a tuple into some array that, again, may be of use. Again, it's just to sort of show you how some of these pieces work together. Alrighty, anyways, folks, with that said, as always, you can track your progress on the deprogramming language series here. And I hope you enjoyed these functional higher order Constructs here, or higher order functions, as map, reduce, and filter are known as. They're quite fun to play around with. I'm really happy that they're part of the Phobos standard library. And of course, there's a bunch of other fun stuff that you can play around with, and we'll certainly look at in this series. Thanks as always for your time and attention, folks, and I'll look forward to seeing you in the next video.